Thanks for tuning into our final presentation. For a bit of background of how we'll go through it is I'll start off with giving you an idea of what our problem was as well as our user stories. Annie will then jump into our Unity prototype and walk you through it. Then Ryan will come on and talk about the information architecture and how it relates to our prototype. And then Sang will end off with telling you how our solution in our prototype addressed our problem. So after speaking to Dan and hearing how him and his other crewmates operate on scene in a firefighting scenario, we realized that firefighters really need a way to communicate, navigate, and respond efficiently when they're on the fire scene. However, they lack the real-time information required to gain situational awareness. And on top of this, current communication channels are insufficient as they involve speaking through a radio with a mask, making speech often inaudible. So to break our problem down even further into 4 specific areas, we can see that all of these 4 areas really focus on helping a firefighter react faster and more efficiently when on scene. So right now, they lack the ability to locate the nearest resources, fire resources. They also lack real-time temperature data to be able to make insightful decisions on the go. There is also poor communication between crewmates as it's often inaudible. And there, of course, is insufficient navigational cues to rely on when wanting to either exit a building or to get assistance. We've broken our problem down into 6 separate user stories to focus on in this prototype. The first is having firefighters see a map of their close surroundings so that they can easily and safely navigate through the scene. Secondly is having the firefighters be able to view the temperature of objects in the room so that they know when unburned gases and other hazards become serious. Third is having firefighters see a mesh over objects in their current view so that they're always aware of where things are. Fourth, the ability for firefighters to have automatic speech to text so that even if they can't hear their crewmates, they can see what they're saying. Fifth is having firefighters set situational alerts or anchors so that they're always aware of alerts relating to hazards, medical emergencies, or other general information. And lastly, to have firefighters be shown directions to fire resources, exit ways, and also to their other crewmates.
So this is a walkthrough of our iteration 3 prototype. Here is the beginning scene of our mini town. So basically this bar here is on fire and the firefighters have just arrived. So the UI of the screen includes a semi-transparent chat box at the top left corner. This displays the conversation history as well as the time messages were sent. Down the bottom here is the chat bar. It's also semi-transparent so that it doesn't interfere with the actual visibility of the scene. This is where users can use the speech-to-text function, and with this button, their message will be converted into text. Dan, could you please check the back? Oh, as you can see, it understood what I was saying. At the top right corner is a mini map, and this shows the GPS location of the firefighters, as well as any other firefighters with their GPS connected on the scene. Situational anchors will also show up here. We will see that later on. There is a toggle checkbox for the user to show or hide the chat bar and the chat box. We plan to extend this toggle function to the minimap as well as the directional arrow over here and the thermometer UI, which you will also see shortly. So a little bit about this directional arrow here in green. This is pointing to the nearest water source, for example, fire hydrants, so that users can easily identify where these resources are and how to get to them if needed. As you can see, if I move, it will continue to point towards the nearest fire source, nearest water source. And as you see, once it is in sight, the arrow disappears and the firefighter knows exactly where to go. We plan to extend this so that the arrow will sit on the ground perhaps and could continue to point at the object until the user arrives at the source, but this is for the further iterations. Cool, now back to the scene. Let's go into the bar. So in the scene, as you can see, there is a massive fire happening right there. The user may wish to toggle off the chat box in the chat bar to see better. In here, you can see that when a user gazes at a specific object, the estimated temperature of that object will appear above it to help the user navigate and approach these types of objects with more confidence in case they are too hot or if they are safe to touch. As you can see, the bar is currently at 200 degrees Celsius. And if you look over here, these tables and chairs over here directly in the fire is currently at 350 degrees Celsius. So this is our first scene, and this is the mini town scene. Cool. So going into our next scene, this is our thermal scene. So in this thermal scene, we have a simulated view of what the mesh functionality would look like, as well as the simulated situational anchors, which we have imitated with the MRTK tooltips over here. So the UI in the scene consists of the thermometer and the minimap. The thermometer will display the range of temperatures detected at the scene, and it will show this with a range of colors. The colors that you see on these objects, for example, the tables, the chairs, the pole over here, these are shown from the hottest, which is red, to the least hottest, which is yellow. And they will also appear on the mini map in the top right corner as well. So as we go through the scene, you can see that there are situational anchors pinpointed at different locations. There will be three main types of situational anchors. The first is the medical anchor, which you see here. Basically, this indicates to the other crew members if someone is in need of first aid. As you can see, there is a man lying here and he needs first aid immediately. The second situational anchor we have is the informational anchor. This is just to communicate general information with the other crew members, such as looking out for a missing ginger cat, or perhaps find the missing 7-year-old daughter who's in a pink dress, for example. And lastly, we have the hazard anchor, and this is for firefighters to place down to show their crew members if there's any dangerous objects in the scene that they might want to look out for. In this example, the hazard anchor currently states that there is a possible explosion around in this area, so this communicates to the firefighters that they should be careful when entering the scene. Currently, the anchor text is a little small, but we plan to scale this larger so it'll be easier to see. And as we mentioned before, we will also be having a toggle on and toggle off button for the mini-map as well as the thermometer, just so the firefighters can have better visibility of the actual scene.
Cool, thanks Annie for that awesome walkthrough of the scene. So now that you have all been able to see how our prototype works in practice, I will now go into a bit more detail about what happens on the back end with this architectural diagram that we made. So starting here at the bottom, we have our actual scene. Now in the scene, we have the mixed reality toolkit that we installed, which we use to emulate virtual reality and augmented reality. And we also have our SQL database, which holds all of our user data. So that's mostly just the firefighter data or their personal data, which is retrieved from Azure. Moving up, we have our custom data sets, which we pull straight from Azure at the top here. So this is essentially an instance report. So each instance will have its own data set, and that is how information will be pushed into and pulled into our Unity scene and Azure. So when looking at Azure, this is where we'll hold our SQL database. I would urge you to go and look at the PDF that we uploaded with our SQL database. It goes into a lot more detail explaining how everything communicates and how the different entities work. So from here we'll go left and then right, I think. So we'll have our Microsoft Cognitive Services, which is where all of our machine learning takes place, which is our speech to text and our proposed use of custom vision. So that will be implemented into our Unity scene. Yep, and then we also have the Unity Asset Store, which connects to our scene, and this is where we pulled a bunch of prefabs, our awesome team medieval theme that we went with, we got from the Unity Store. And then going on to the right here, we have Azure's cloud services, or Microsoft's cloud services, which is how Azure and Unity communicate with the internet, here on the far right. We'll also pull data into Unity from an API, which is how we'll randomly spawn fire trucks into the scene. So yeah, that's essentially how our data structure works within the scene. So cool. Thanks everyone, and enjoy the rest of the presentation.
For our prototype, we focused on communication, navigation, and situational awareness to allow firefighters to effectively respond and effectively fight fires in the safest way possible. To solve our first key problem regarding the inability to locate the nearest fire resources such as fire hydrants, we have included directional indicators in our UI in the form of green arrows which direct firefighters to the nearest fire resources they seek. This allows firefighters to have more situational awareness and navigate faster to resources when they are needed. Our second key problem of having a lack of real-time temperature data feedback to help with decision making is solved by having a temperature gauge within our second UI. This allows firefighters to assess the situation much more effectively as they can navigate between safe areas and evacuate potential danger areas before they become hazardous for the firefighters. Our third key problem focused on poor communication between crewmates as audio quality is limited during a fire. Therefore, we incorporated speech-to-text, which allows crewmates to speak as the AI records and sends the message in text form to allow other firefighters to accurately read important messages when audio is unavailable. Our fourth and last key problem was that firefighters had insufficient navigational cues, which made it difficult for firefighters to communicate potential dangers and also difficult to ask for assistance. This was solved through our mini-map and situational anchors, which allows firefighters to have a live view of all other crew members through the minimap, and lets all crew members have the ability to place situational anchors in accordance to their situation. We included a first aid anchor which can be placed when firefighters need assistance with a patient, a hazard anchor to allow firefighters indicate other crewmates of potentially hazardous areas, and also an informational anchor which can be placed to give additional information of certain areas where assistance may be needed. All anchors are visible through the minimap, therefore allows all firefighters to navigate easily and give assistance more effectively when needed. In conclusion, we have created a prototype to allow firefighters to more effectively assess each situation through better communication, navigation, and situational awareness. We have incorporated a number of functions to help firefighters fight any blaze as safely and effectively as possible, and refined all functions to give an idea of how our prototype will work in the real world. Thank you.